Hey everyone, and welcome. Today, we're pulling back the curtain on the secret sauce behind modern smart cars. It's this incredible engineering revolution called model-based development. And trust me, it's the hidden blueprint that lets car makers build the amazingly complex vehicles we drive every single day. So, let's dive in.
So get this, that car sitting in your driveway probably has more lines of code than a fighter jet. That's insane, right? It's basically a supercomputer on wheels. So how on earth do engineers manage all that complexity? How do they make sure everything, from the brakes to the battery, works flawlessly without, smashing a bunch of prototypes into a wall first? That's the big question we're tackling. To really appreciate the new solution, you first have to understand the old problem. For years, building complex software was, it was a pretty risky road. You'd have teams of people handwriting thousands of lines of code. Then you'd build a physical thing, and only then would you find all the critical bugs. That old way just can't fly anymore.
And this comparison right here just lays it all out perfectly. On the left, you've got the old, tangled mess. You're finding bugs way too late, which means crazy expensive delays. But on the right, you see the model-based development approach, or MBD. Here, you're catching problems super early in a virtual world. The code basically writes itself, and you can trace every single decision from start to finish. It's a total game changer.
So, this brings us to the star of the show, model-based development. The big idea behind it is actually pretty simple, and it's all in that phrase. Design first, code later. It's all about perfecting the blueprint before you even think about laying a single brick.
So what is it really? Well, at its core, MBD is a way of working where engineers build these visual, functional models of a system. So instead of typing out endless lines of code, they're using graphical blocks and flowcharts to map out the logic. And this model isn't just a pretty picture. It's a living, breathing simulation you can actually test.
And I love this analogy. Just picture it. You have a perfect digital twin of your car's brain. You can push it to the absolute limit, slam on the virtual brakes during a simulated blizzard, see how the battery holds up on a scorching hot day. And you can do all of this from the safety of your computer, way before any real metal gets bent.
This workflow really shows you how it all clicks together. First, engineers model the whole system visually. Step 2. They run a ton of simulations to find any and every flaw. Then, and this is where the magic happens, the software automatically generates the actual production-ready code right from that model. Finally, that code gets tested like crazy before it's deployed to the car's hardware. It's just so much cleaner, more efficient, and way more reliable.
All right, so this isn't just some theory they teach in a classroom. This is the industry standard that's powering the cars you and I see on the highway every day. So let's take a look at how MBD went from being this niche idea to the undisputed king of the hill in the auto world.
Wow, this chart just says it all. Look at that curve. It went from, 10% adoption back in the early 2000s to basically everybody using it today. This wasn't some slow and steady change. It was a lightning-fast transformation, all because cars were getting way too complex and way too dangerous to build the old way.
So what are we actually talking about here? What features run on this stuff? MBD is the invisible brain behind almost every critical system in your car. That collision avoidance that might one day save your life? Designed with MBD. The super complex battery system in an electric vehicle? Yep, MBD again. Even your anti-lock brakes and that fancy digital dashboard. All of it was designed, simulated, and perfected with this method.
Okay, so we know it's everywhere, but what are the actual tangible benefits? The numbers here are just staggering. It really boils down to 3 things: working faster, building safer cars, and doing it all in a much smarter, more cost-effective way.
First up is speed. We're talking about getting new cars and new tech to market up to 30% faster. In an industry as competitive as the auto world, that's not just a small advantage, that's the difference between leading the pack and eating dust.
Now for what I think is the most important number, a 40% reduction in failures out in the real world. Think about that. That means nearly half as many critical software bugs in things like your car's braking system. This isn't just about saving a company's reputation, it's about saving lives. And finally, let's talk about the bottom line. When you find bugs in a virtual model instead of on a physical prototype, you can slash your testing costs by half, a full 50% savings that comes from designing smarter from the very beginning. And hey, if you had any doubt left about how dominant MBD is, this stat should just wipe it away. A whopping 85% of the big car companies rely on this process for their most important, most safety-critical systems. When the stakes are this high, this is the method they trust. Period.
Now, this is about more than just how cars get made. This is about a huge and growing career field. So for anyone out there in engineering or tech, understanding MBD isn't just a cool fact. It could be your ticket to working on some of the most exciting projects on the planet.
The demand for these skills has created this whole world of high-paying jobs. Companies are desperate to find MBD engineers to build the models, control systems engineers to design the core logic, and embedded software engineers who make it all work on the actual hardware. These folks are literally the architects of our modern tech world. And, they're definitely well-paid roles. As you can see here, even an entry-level job can start in that $80,000 to $95,000 range. Get some experience under your belt, and you're easily into six figures. And the senior folks, they can pull in $150K or even more. It's a field that really values expertise.
But do you want to know the best part? These skills are incredibly transferable. The exact same methods used to design a car's stability control are being used to design a rover for Mars, or a surgical robot, or a drone's flight system. Learning MBD doesn't just open doors in the car industry, it opens doors across all of cutting-edge technology.
So, when you boil it all down, model-based development isn't just an engineering trend. It's the fundamental blueprint for the smart, complex systems that are shaping our future. We've seen it take over the auto industry and aerospace, so the only real question left is, what industry is it going to transform next? Thanks for watching.